All right. Hey, Riti. So I would request everybody to keep their videos on.
Hi, sir.
No, beta. No, Vihan. Not Vihan. It's Arihan.
Yeah.
Yeah. Arihan, do you mind turning on your video? Because in this class, I request all the kids to keep their videos on so that I can see you guys and I don't feel like robot.
Wait, is the camera on?
No, it's not. You have to turn it on. So let me do. Hello, Yog. Let me
Yeah,
do.
I'm clicking the.
Hmm.
I'm clicking the button. It's like not working.
It's fine. That's fine. I mean, if it works, wonderful. If not, it's fine. So let me do a quick roll call and then we'll start. So we have Aradhya, Aditi, Asher, Mandeep, and then Suhina, Nihan, Sanvi, Sami, Praneet, sorry, not Praneet, Nihit, Srianvi, then Arihan and Yuk. And I would request everybody, whoever for whom the camera is working, keep your camera on so that we can make eye contact and interact with each other. All right. So today being a Saturday, we'll first check the tables. All right. Everybody turn your video on. Yug, your video was working. Shranvi, your video was working. Sammy's video was working. Keep it on. Okay. So, who should we start with? Okay, Mandeep. Mandeep, table till.
No. I can't on my video.
That's fine. That's okay. I mean, if there's a technical problem, just ignore that part. But yeah. So let's start with Aditi then. Aditi, table till.
12.
12. 8 9 ja.
72.
9 5 ja.
45.
12 6 ja.
72.
9 9 ja.
81.
8 7 ja.
8 sevens are 56.
12 8 ja.
96.
Good job. Let's go to Asher. Asher, ready?
Yeah.
Table till.
11.
9 9 ja.
81.
7 5 ja.
35.
7 6 ja.
42.
11 8 ja.
88.
8 8 ja.
49.
8 8 ja 64. That's 7 7 ja 49. Okay. Now Mandir's camera is also working. Good job. So you just missed 8 8 ja, but that's no damage done. I mean, we just have to keep on practicing tables for 2 3 minutes every day. Okay, and make sure that you do it like a sport. Memorize them. Catch hold of somebody in the family. Say, okay, ask me questions. So play with the tables. That's what I would suggest. Okay.
Okay.
All right. Let's go to Nihan. I was seeing Nihan waving his hand, saying hello. Okay. Table till
13.
13. 13 5 ja.
14.
13 5 ja.
65.
5 9 ja.
What?
5 9 ja.
45.
8 8 ja.
64.
12 7 ja. 12 7 ja.
What?
12 7 ja.
Oh, 84.
9 9 ja.
81.
Good job. Let's go to Sanvi. Sanvi, ready? Table till
11.
11. 8 7 ja.
56.
9 5 ja.
45.
8 9 ja.
72.
7 7 ja.
What?
7 7 ja.
49.
11 8 ja.
88.
9 8 ja.
72.
Good job. Let's go to Suhina. Suhina, did I say your name right?
Yes, sir.
Okay. See, I'm not that bad with my memory. All right. Table till
13.
13. Okay. 8 7 ja.
56.
12 9 ja.
108.
13 7 ja.
9. Wait. 13, 7 is 91.
91. 12 6 ja.
72.
9 9 ja.
81.
7 9 ja.
63.
12 5 ja.
60.
Good job. So again, I know it gets little exciting and you guys keep moving further, but in your grade, if you guys are comfortable till table 13, trust me, you are way ahead of even kids in the high school. Okay, if you master table till 13 or 14, I can tell you that there'll be at least 60% of the kids in high school who would not know table till 14. Okay, so let's focus on mastering table till 14 and then we can keep flexing about it. All right, Mandeep, ready?
Yes.
Table till
12.
5 9 ja.
What?
5 9 ja.
45.
9 7 ja.
63.
12 4 ja.
48.
11 7 ja.
77.
12 9 ja.
108.
Good job. All right, let's go to Arihan. Arihan, ready?
Yeah.
Table till
12.
8 8 ja.
64.
12 5 ja.
5.
12 5 ja.
60.
7 9 ja.
63.
12 9 ja.
108.
9 9 ja.
81.
7 9 ja.
79. 63.
Good job. Now let's go to who's remaining. Who is not? Shriyanvi, ready?
Yeah.
Table till
Oh.
I could not hear you, beta. Say that again. Table till
12.
12. 9 9 ja.
72. 81.
8 8 ja.
64.
12 5 ja.
12 as a 60.
7 9 ja.
63.
12 6 ja.
72.
11 9 ja.
99.
7 8 ja.
56.
Good job. So now let's see who are remaining now. So Yug, table till
8.
8. Keep your video on. And sit down. Okay. Yeah. I know it's cold, but yeah. 6 8 ja.
48.
7 5 ja.
35.
5 9 ja.
45.
6 9 ja.
54.
7 8 ja.
56.
8 5 ja.
40.
Okay. So I have no complaints with you answering it. Okay. Now I want to repeat myself that you have to practice it every day. Okay. 5 minutes. I know you love sports. You play a lot. So I want you to play with tables also. Okay. Play with tables, memorize them, and then take the table, catch hold of somebody in the family and say, okay, ask me questions. I would want you to cut down on the time it takes for you to say 8 7 ja 56. I want it to be like 8 7 56, like this. As if somebody asks you what is your name, you say Yug. You don't calculate, right? Same way. Alright? So that's what we have to practice for. And the only way you can do it, or anybody can do it, including me, is by memorizing it every day, okay? So make sure that you spend 5 minutes honestly with yourself to memorize the tables. If you are saying table till 8, I want you to be solid with table till 8, okay? And that's not only for you, for everybody here. That's why I'm saying don't rush to get to 16 or 17. While it sounds very exciting, but make sure that you stay focused, and whatever you memorize, you become a champion. There's nobody who can prove you wrong, okay? That would be our goal. So 5 minutes every day, play with it, take it to your parents, ask them to ask you questions, and then you see whether things are improving or not, okay? Keep practicing. That's the only way. Because if you memorize tables, you will find math becoming much more fun. Yeah, Mandeep, you're saying something?
Are you in your house?
Mm-hmm. So it's very cold in the garage. That's why I'm doing it inside the house. Okay. Okay. You might want to go on mute so that. Okay. Let's go to Sami.
Yes, sir.
Sami, table till.
12.
Okay. 8 9 ja.
72.
12 5 ja.
60.
9 9 ja.
81.
11 9 ja.
99.
10 8 ja.
80.
6 7 ja.
42.
12 9 ja.
108.
Good job. So now let's see who all are remaining now. Aradhya has not spoken yet, and then Nihit has not spoken yet, and Salni has not spoken yet. So Salni, are you ready?
Yes, sir.
Okay. What happened? You sound sad. Is it because of snow?
I just went outside and came.
Okay. No, I'm just. You were sounding, yes, sir, as if somebody has punished you. Okay. All right. Table till 12 8 9 ja.
72.
12 7 ja.
84.
9 8 ja.
72.
12 6 ja.
72.
5 9 ja.
45.
9 8 ja.
72.
12 9 ja.
108.
Good job. So regardless of how you all have done, make sure that you're spending 5 minutes every day. Now Aradhya, ready? Aradhya, are you ready, beta? Yeah. Table till. I cannot hear you, Aradhya. You stop playing with emojis, beta. Yeah. Can you hear me now?
Yeah.
Yeah, I can hear you as well. Okay. All right. So table till
7.
6 5 ja.
30.
4 9 ja.
26. 4 9s. 36.
5 5 ja.
25.
6 6 ja.
36.
7 3 ja.
21.
7 5 ja.
35.
4 8 ja.
32.
7 7 ja.
49.
Good job. So you have memorized tables, but keep practicing it, okay? So 5 minutes daily, that'll do the magic, okay?
Okay.
All right. So who is remaining now? Now, Nihit. Where is my friend Nihit? Nihit, turn it on. Table till
6.
5 5 ja.
25.
6 6 ja.
36.
5 9 ja. 45. Okay. 6 4 ja.
24.
5 8 ja.
40.
3 9 ja.
27.
5 4 ja.
What?
5 4 ja.
20.
20. So, see, I can clearly see that you are practicing table as well. But then, there is something called practice makes a man perfect. You are not a man yet. You are still a baby for me. But keep practicing it, okay? Every day 5 minutes. I would want you to be as quick and as accurate as possible when it comes to knowing tables. Not only you, everybody in the class, okay? Alright? And I will try to talk a little less today because my voice has become funny. I can sing interesting songs today. Okay? So, alright, coming back to serious business. So, what we have learned till now, I think everybody has shared the tables, right? I think, yeah. So, what we have learned so far, we had started learning about the basic properties of all the shapes. We started with lines, line segment, rays. Then we went to two lines, that is when we saw parallel lines, and then we saw angles. And within angles, we saw three variants. What are those? There are three types of angles. Yeah, Nihan.
Acute angle, obtuse angle, and right angle.
Yeah. And Sanvi, what is the difference between the three?
Obtuse is like very big. Acute is like very small, so since it's cute, and the right angle is not too big or too small. It's just the right size to make a right corner.
Okay. Mandeep, can you tell me that mathematically what's the difference between the three?
The difference between the three is that they all have like large, medium, and small, and they're not the same size.
So you are telling me the t-shirt size, okay, large, medium and small. And somebody fat like me wears large, somebody small like you puts a small t-shirt. Okay, yeah, let's see what Aiti has to say. Yeah, Aiti.
The right angle is different because that the obtuse is bigger than 90 degrees and the acute angle is lesser than 90 degrees.
Exactly. So 90 degrees your border, okay? If it is 90 degree, it's right angle. The two walls standing right against each other. When it is less than 90 degree, angle is small, looks cute, a cute angle. When the angle is like this, when my wall is falling on my neighbor's wall, that is called, this is 90 degree, it's called obtuse. Yeah? Alright. So then we talked about angles. Then we talked about triangles, where we said triangles, again, you guys were supposed to tell me a story in 2 minutes to explain me all the types of triangles, where we came to a point say, okay, triangles, you can categorize them based on, triangles is a shape which has 3 sides and 3 angles. You can categorize them based on sides. Hey Tasvik. So you can categorize them based on sides or based on the angles. When you talk about sides, there are 3 types. They are called, based on sides, there are 3 types. Yes, Alne. Yeah, Rihan. Yeah, you go ahead.
A three-sided shape would be a triangle.
Three-sided shape will be a triangle. I'm saying in any triangle I have three sides and I have three angles. So there could be different types of triangles based on side and based on the angles. So when we look at triangles with sides in mind, there are three types. What are those three types?
I only know one, and I think it's like isosceles or something.
Yeah. So equilateral, isosceles, and scalene. When all the three sides are same, it's equilateral. When only two sides are same, isosceles. And then when all three sides are different, that is called scalene triangle. Yeah? Do you recall, Arihan?
Yeah.
Now, when you look at angles alone, based on the angles also, you have three types of triangles. Who remembers that? Yeah, Niti.
One of the triangles have the equilateral triangle has three acute angles on each side.
Okay, yeah. Tasvik, what would be the difference, the three types, based on the angle? Tasvik, your turn. You're probably talking on mute. I cannot hear you.
Acute angle, and right angle.
Obtuse angle, acute angle, and right angle. So three angles or three types of angles that we learned. If you have all the angles less than 90 degree, meaning all the angles are acute angles in a triangle, that's called acute angle triangle. When you have one of the angle is 90 degree, that's called right angle triangle because this is a right angle. And when one of the angle is more than 90 degree, that's called obtuse angle triangle because you have an obtuse angle, right angle. So if you have a right angle, that's right angle triangle. When you have an obtuse angle, it's an obtuse angle triangle. When you have all the angles as acute angles, that is called acute angle triangle. Yeah, everybody recalls that. Now, beyond triangles, we went to the next shape, that is called quadrilaterals. Yeah, and I would suggest you guys not to play with emojis because that will get you distracted and your focus will be on emojis, not on the teacher. Okay, so when you talk about quadrilaterals, who remembers what is a quadrilateral? Yaditi.
A quadrilateral has four sides.
Yes.
And it has like four right angles on each, like a square hat.
So I will say any quadrilateral has four sides and four angles. Now within that we have different varieties. Yeah, let's see what Sanvi has to say. Yes, Sanvi.
Different quadrilateral have different angles.
Okay.
Like a rhombus has acute and a rectangle has like a right corner, a right angle. But like it's sometimes same because a rectangle has a same angle to a square.
Okay. No, I think you guys are going way too far. Let me stop you guys a little bit and then we'll revise it and then we'll move on to this thing. Okay, these are 6 shapes that you would need to know as part of a quadrilateral. This one is a rectangle. Everybody remembers, right? What is the property of rectangle? I'll just quickly run through this quickly because we have covered this in the previous class. So I just want to make sure that we learn something new as well. So here in the rectangle, what happens is the opposite sides are equal. So this is equal to this one and this is equal to this one. And every angle is 90 degree. Okay. And I see that no, you guys have understood things, but when it comes to telling a story or teaching your teacher, you guys go in different directions. So I would say after the class also, whenever you get time, just spend few minutes to watch the video, just to revise the concept and note it down for yourself in your own way, so that you don't end up forgetting things. Okay, because see these properties that we learn now, that is going to be our building block for playing with geometry in future. Okay, if you get used to these concepts at now, trust me, geometry and trigonometry will become fun for you guys in the higher grades. If you miss the concepts now, we'll have to do it one more time. Yeah?
Isn't this geometry?
This is geometry, but this is the elementary geometry.
Okay.
And it's going to be more, there are going to be more intricate details to it.
What's trigonometry though?
Trigonometry is, see a triangle which looks very cute, right? This is right angle triangle.
Mm-hmm.
This is the mother of the subject trigonometry. Everything revolves around this right angle triangle, okay? So if you know the concepts well, this one will become the building block of a new subject altogether. Okay? Let's not worry about that for now, but yeah.
There's different types of geometry.
Maybe you can park that for now, because if you guys try understanding everything now, it might get a little confusing. Yeah, Rihan, you're saying something. Alright, so this is the first type of quadrilateral, which is called rectangle, where the property is the opposite sides are same. This and this are same, and every angle is 90 degree. And then there's one more property that you might want to remember, that is the opposite sides are parallel also. Yeah. So if you have to define a rectangle, let's say if you have to define your teacher, what would you say? You will say, I learned math from a teacher named Birendra Kumar. He is an old guy, wears glasses, he has less hair. That is my property, correct? Same way, when you have to define a rectangle, what will you say about rectangle? You will say rectangle is a quadrilateral where the opposite sides are same and parallel, and every angle is 90 degree. That is a property of a rectangle, right? Every shape. Yeah? Like I'm a shape. I look like a shape, right? Something, I have certain properties. When I have to define, let's say one of the kids in the class, let's say Tasvik. I'll say Tasvik is a small child who studies in elementary school, and he wears glasses. He has long hair, much longer than mine. Okay? That's Tasvik's property. Correct? So same way, every shape has a property, has some properties that we need to be aware of. Now when you look at this one doesn't look like a square, but I'll still call it a square. Okay? Let me draw a better square. So this is a square. What is the property of a square? Anybody remembers? Quickly. Let's see if Arihan wants to say something. Let's see. Arihan is the first. This is first class for him. I want to. Yeah, Arihan.
So every single angle of a square is 90, and then two sets of parallel.
Okay.
And all of its sides are like length and width are equal.
Yeah. So basically, you will say, see, this is in the case of rectangle. What happened was only the opposite sides were equal and parallel, and every angle was 90 degree. In case of square, you will say all sides are same and every angle is 90 degree. That's it. And opposite sides obviously parallel. Yeah. Now, this one. This is rhombus. Yeah, Yug.
Can I go to the bathroom?
Yes, please. What is this one? A rhombus. Yanihan.
I can't raise my hand in the meat.
That's okay. You can raise your hand like this. I can notice that.
Oh, okay.
So what is this one? Rhombus?
Wait, me?
Yeah.
It's a rhombus and it's equilateral.
Say that again. It's a rhombus.
It's equilateral.
Equilateral. Equilateral. Yeah, that's a good term. Equilateral meaning all sides are equal. Lateral means side. Equi stands for equal. So all the sides are same, but that is not enough to define a rhombus. Let's see what Sanvi has to say.
They're all the same angles.
Rhombus, see these opposite angles are same. So this one and this one are same. This one and this one are not. This one and this one are same, and this one and this one are same. Only the opposite angles are same. So let's see what Aditi has to say. Yeah, Aditi. Aditi, you are mute.
A rhombus is even often called a diamond because if you turn the rhombus like this way from its normal spot, it'll look like one diamond.
Okay, that I would agree, but that's not a mathematical definition. Let's say what Shanvi has to say. Yes, Shanvi.
So opposite sides are congruent.
Say that again.
Opposite sides are congruent, and all four sides are the same in length.
So opposite sides are congruent. You used a very loaded word, congruent. So congruence is something that we will probably learn a little later. But here the basic definition of a rhombus is all the four sides are same and the opposite angles are equal. Let's see what Sammy wants to add. Yes, Sammy.
I didn't want to add anything. I just had a small question. Whenever I was younger, I used to think when you turned a diamond like this way, it was a square. But now looking at the shape, it will be a parallelogram. Was my question.
So look at it this way. So this is this is a square. Okay. This might not look like a square, but assume it to be a square. And when I squeeze it, when I press it from this corner, what happens is it becomes taller. So this angle, which was 90 degree in the case of a square, became shorter than 90, and this angle, which was 90 degree, became bigger than 90 degree. So now it has distorted. It will never look like a square or anything else. It will become a rhombus, or a rhombus. If you want to visualize, you can always think of a rhombus like a squeezed square. When you hold two corners and squeeze it, it becomes taller and thinner. So here it became smaller angles. When you squeeze it, this became smaller, this became smaller, and this opened up, this widened. So the length of all the sides are same, like the square, but it became thinner and taller. Okay?
Okay.
Yes, Ali, you want to say something?
Yeah. When you tilt the rhombus, it will become a parallelogram.
What? No. What? Say it again.
When you tilt the rhombus, it will become a parallelogram.
So rhombus is a parallelogram, no question about it, because the opposite sides are parallel. Since we have not talked about parallelogram so far, this is a parallelogram where the opposite sides are equal and parallel. So the basic difference between a parallelogram and a rectangle is, in case of rectangle, opposite sides are equal and parallel. Here also we have opposite sides equal and parallel, but the angles are not 90 degree, may or may not be 90 degree. Okay, there is no condition. You cannot have a rectangle where the angles are not 90 degree. Okay, so parallelogram is a wider group where every quadrilateral where the opposite sides are equal and parallel is a parallelogram, regardless of whether the angle is 90 degree or not. Yeah. Yes, Anvi, you're saying something.
The parallelogram kind of looks like a rectangle, but except the parallelogram is like tilted back.
Yeah, so basically when you tilt a rectangle, right? You have a rectangle like this, and you said, I want to move this side. So from here you move to this place. So the top side which was here, you shifted that. Okay? So this became a parallelogram. A rectangle is also a parallelogram. I'm not denying that. What I'm saying is, by definition, a parallelogram is a quadrilateral where the opposite sides are parallel and equal to each other, regardless of whether the angle is 90 degree or not. If the angle is 90 degree, you'll call it a rectangle. If the angles are not 90 degree, you'll call them parallelogram. As simple as that. Yeah? So we have learned the property of a rectangle, a square, parallelogram. And then and rhombus. In the rhombus, there is one more thing that I had told you guys, which you might have forgotten. That is, in a rhombus, when you join the opposite corners, these are called diagonals. Diagonals of a rhombus bisect each other perpendicularly. Meaning, when you join the two opposite corners, they meet each other at a point where this side is equal to this side is equal to this side, and they meet at 90 degree. So again, I'm repeating myself. If you want to look at a rhombus, rhombus is nothing but a square which is squeezed from two corners. So it becomes taller and thinner. So that means all the four sides will be the same, but the angles are not 90 degree. That's the basic difference between a rectangle, square and a rhombus. Now, in case of rhombus, what happens is, when you join the opposite corners, these are called diagonals. And diagonals meet each other at 90 degree, and then they divide each other equally. It's called, they are perpendicular bisector. So if I have a line like this, if I say perpendicular to this line is perpendicular to this line, or this line is perpendicular to this line, what does it mean? They meet at 90 degree. Okay? And bisect. When you say bisect, meaning split into two equal parts. So the diagonals of a rhombus bisect each other perpendicularly, meaning they are perpendicular, making 90 degree, and they divide each other equally. Okay? That's a property I would want you guys to remember, because that will help you find out how to find the area of a rhombus. Okay? I will never ever give you guys a formula, say, okay, this is the formula for area for rectangle, this is the area for square, this is the area for rhombus. I will tell you how those formulas are derived, so that it remains with you forever. Yes, Anvi.
For a rhombus, is all sides equal 90?
No. All sides are equal, but angles are not 90 degree, because what you have done is you have squeezed the square. You had a square where all the sides are equal and every angle is 90 degree. What you did, you squeezed. You would have seen some toys, okay, where you can squeeze it. When you squeeze it from these two corners, it becomes like this. It becomes taller and thinner. Yeah? Yeah? You would have seen some toys. I mean, I'm not able to find one, but if you have a toy like this, which has four corners, you can squeeze it, it becomes taller and thinner. Okay? I'm sure you will see something around yourself. If I find one, I'll show you guys. Okay? So this is the rhombus. Now, next one is called kite. Do you know what is the difference between rhombus and kite? Yes, Salni.
Like a rhombus, it's like they have parallel sides, and then a kite, like the down part, is like bigger than the upper part, and also it's like
Not convincing. Let's see what Arihan has to say.
Me?
Yep, you have raised your hand.
I was about to say that you know, like the middle part where like you drew the horizontal line. It's like vertical line. So I see that that's like much taller than the one on the rhombus.
That could be an observation, but not the definition, mathematical definition. Okay, let's see what Sami has to say.
So the differences of a kite and rhombus, right? Okay. So exactly what Shalini said, but a kite has a more defined shape because you can just tell that a rhombus is just a square squeeze. But for a kite, you actually have to explain what it is, and it has a more architectural shape than the rhombus.
Okay, that's a loaded definition. Let's see what Shanley has to say.
I know one property of wait, did you say the difference between?
No, just tell me what is a kite. I mean, what are the properties of a kite that you remember?
So a kite is a quadrilateral with two equal sides and two unequal sides.
Okay, let's see what Nihal has to say. Yeah, Nihal. You're talking on mute. Yeah.
One of the differences between rhombus and kite is about the angles and the shapes.
Okay, so let me give my definition now. So Aditi, I think I'll use the time to give my definition. I heard everybody, and you can validate, Aditi, whatever definition I'm giving. So if you look at rhombus is a squeezed square. So you had a square, you squeezed it, so all sides are same, but angles are not 90 degrees. Kite is different, meaning where you will see that the top two sides and the bottom two sides are equal to each other. These two sides are same, these two sides are same. I'm not sure who all has, Mandeep, sit down, beta. Okay, so in case of a kite, you will see these two sides are same, these two sides are same. Okay, I'm not sure if anybody has got a chance to play with the kites. When we were small, we used to fly kites. Okay, where you will
play with the kites.
Yeah, play with the kites, flying. Okay, so actually there is a festival coming up in few days from now, which is called Sankranti. That is when we used to fly kites. Okay, so where these two sides and these two sides are equal. And another thing that you would want to remember is when you join the opposite corners or the diagonals, they meet each other at 90 degrees. That's it. They meet at 90 degrees. Okay? They don't bisect. In case of rhombus, what happens is the diagonals meet at 90 degrees and they bisect each other, meaning this side and this side are same, this side and this side are same. In case of rhombus, they just meet at 90 degrees. Sorry, in case of kite, they just meet at 90 degrees. Okay? So again, look at kite and look at rhombus. What is the main difference? Here you have all four sides same, here you have only two sides and these two sides same. Okay? Second thing is, here diagonals meet and at 90 degree, here also it meets at 90 degree, but here the diagonals bisect each other, here they don't. Okay? That's the main difference. So rhombus you get by squeezing a square, kite is a different shape altogether. So maybe that's what Sammy and Salni were trying to say. There's a different architecture altogether. But probably that's a loaded definition. What I was saying was every shape that you look at here in geometry, you have to look at the properties. What are the properties? Sides and the angle. That is the property. So every definition that you talk about will be with respect to the side or with respect to the angle. Does it make sense? Yeah, Tasvik.
Can I go to the bathroom?
Yes, please. Yeah, Diti. Does it clarify it?
A kite is different than a rhombus.
Yeah.
Because one of the two upper diagonal lines go shorter, and the bottom ones go long.
Right.
Very long.
What you would say is the bottom two sides are equal to each other, top two sides are equal to each other. Yeah. Because I can flip the kite upside down, then what is my top, what is my bottom changes, right? But the shape will still be called a kite. So that's why I would not say the bottom one is longer and the upper one is shorter. I'll just say the upper two sides and the bottom two sides are equal to each other. Yeah. Alright. Now the last shape. Parallelogram we talked about. Now let's talk about trapezoid or trapezium. Who knows about it? Who can define? Who can teach the teacher now? Okay. Yeah. Aditi and Sanvi. I'll come to you guys one by one. Yeah, Aditi.
A trapezoid has like a trapezoid is like a half of a hexagon. Well, and and it's like and it has I think and it has like I think it has one pair of parallel lines up and down.
Yes, you got 1 point. One strong point. Let's see what Sanvi has to say. Yes, Sanvi.
That there are like different angles,
Uh-huh.
and the side one, the one on the right, the corner one is a cube.
No. That I mean, see, I can play with it. I can change the shape. Okay. So I'm just trying to get the definition. I'll come back to it. Okay. Let's see what Sanvi has to say. Yeah, quickly, Sanvi. Sanvi, quick.
Did you say? Oh.
Yeah.
Yeah. It has one pair of parallel sides.
Uh-huh. So now, without going to each one of you, okay? Very simple thing. When you talk about a trapezoid or trapezium, okay? This is a quadrilateral because it has 4 sides. 1, 2, 3, 4. Obviously, it has 4 angles also. And the only way you define is, you say that it has only one pair of parallel lines. You will say only one pair of parallel lines. Because if you have 2 pairs of parallel lines, meaning this one are parallel, this will become parallelogram. So it has only one pair of parallel lines. Okay? There is no other way to define it. Remember the definition of parallelogram. What does it say? When you have opposite sides are parallel or equal, meaning this is one pair and this is another pair. So basically you have 2 pair of parallel lines. In case of trapezoid, you have only one pair of parallel lines. Does it make sense? Yeah, Mandeep.
It does make sense.
How about you, Sriyanvi? Saying something?
Yeah.
Okay.
I was just gonna I was actually kind of like so a trapezoid, is it basically kind of like a rectangle, but like the upper part is like smaller?
So, see, the problem is, if you ever say a trapezoid like a rectangle by definition, okay, says that your opposite sides are equal and parallel and every angle is 90 degree. That is not the case. So, trapezoid can never be a rectangle. So, trapezoid is a quadrilateral which has 4 sides. Yeah. And then you say there's only one pair of parallel lines. Yes, Arihan.
I was about to say at the top, at the top half, it looks like both of the angles are obtuse, and then on the bottom, both of them are acute. Is that what you mean?
That could be a good observation, but I am a very bad guy. What I will do is I'll flip the trapezoid upside down, and my trapezoid then looks like this. Okay. So what happened is, this was a trapezoid before. I had some mischievous plans. I flipped this guy upside down. So my definition goes for toss, saying top angle is obtuse and the bottom angle is acute. But this is still trapezoid. So the safer definition is, a trapezoid is a quadrilateral, meaning a shape which has 4 sides, where only one pair of lines are parallel to each other. Now whether you look at it here or here, both are trapezoid and nobody can counter argue that. Yeah?
Yeah.
Alright. Now we have talked enough about shapes. Let's look at what do we do with the shape. How do we use our knowledge, understanding of the properties for doing some mathematical calculation. Is everybody ready? Yeah.
Yes, sir.
Okay.
Yes, sir.
Now, there's one more thing I would want you guys to be aware of. And let me just check. Asher has not spoken for some time. Asher.
Yeah.
No, I'm just checking everybody, okay? That everybody is with me, okay? I should not make anybody fall asleep. That's why I'm just checking, okay? So Asher, Nihit, Yug, everybody with me, right?
Yes, sir.
Okay. Aradhya. And I would, okay, don't play with the emojis. Stop it. So, I'll keep on asking you guys, okay? Suhina, Aradhya, everybody to participate, okay? Because when you guys participate and answer things, that gives me more confidence that, okay, whatever I'm telling, I'm not telling it to myself or to the computer screen. I'm telling it to you guys. Yeah? Alright. Now, there's one more thing I would want you guys to be aware of before we start dealing with the mathematical side of geometry. This is where we'll learn about area and perimeter and how those formulas are derived. Just telling you that, okay, memorize this formula doesn't take you anywhere. So we'll have to learn how those formulas came into existence. What does it mean? How do we use them? Guys, stop playing with emojis.
I suddenly did it and everybody's talking.
Okay, no. So I mean, don't keep on adding more things. If one person does by mistake and everybody starts playing with it, not good. Okay. Now, if I have a shape like this, do you know what is this called? Yeah. Yeah, LT.
It's a pentagon in the shape of a house.
Okay, it's a pentagon, okay. Now, can I break it into two parts and say it's a pentagon which I can break into a triangle and a rectangle. Can I do that? This is called compound shapes. Hey, Nihit, don't play with emojis. You can say yes or no to me by muting yourself. That's fine. Alright, so this is called compound shape. If tomorrow somebody says, I have a shape like this, find out the area of this shape. There is no formula that exists. But you can always break a bigger shape into smaller, simpler shapes. See? Now what do I have? One triangle, this is another triangle, this is another triangle, this is another triangle. So now I can look at what is the area of this triangle, this triangle, this triangle, this triangle. That will give me the total area of this shape. So that is about compound shape, okay? Don't worry about that for now. We'll come to this in future, not right now. But what we want to do today is, we just want to build the basic understanding of what is area and what is perimeter. And then we'll start learning how to find out the formula for different shapes that we have learned so far. Okay? So, what do you see on the board? Yep, reality.
Circles ranging from small to big.
Okay. How about you, Asher? Same. Tasvik, anything new you want to share? Same. Okay. Now, think a little bit more. Yeah, Sami, you want to say something?
Yeah, each one is taking up lesser space on the board.
Each one is taking different space on the board. Yeah?
Yeah, that's what I was about to
Yeah.
say.
So this one is taking less space, this one is taking more space, this one is taking more space. In mathematical terms, we don't say space, we say area. This one needs less area, this needs more area, this needs maximum area among the three shapes. So when you say area, now you would have heard people talking, say, okay, there's a lot of area in that house. What does it mean? You have a lot of space. It is built on a bigger surface. So when you talk about area, this triangle and this circle, if I look at it and ask you guys to compare, which one needs more area? It's no brainer, right? You'll say that this one needs more area. This one needs less area. Okay? Yeah. So area is the space taken by any shape on the surface where you are drawing it. If I talk about drawing this house on this board, would you be able to do it? Probably not, because drawing the house needs much more space. This is a much smaller board. Yeah. So area is nothing but the space taken by that object on the surface where you are trying to draw it. Yeah. So I'm just trying to build that understanding about what is area. Okay. We have not dealt with any of the formulas so far. That's what we're going to learn in the class tomorrow. Okay. Yes, Anvi, you're saying something?
No, it's just my hand has stayed up.
Okay, not a problem. Shalini, Sami. Okay.
No.
Okay. So when you say area, it simply means the space taken by that shape on the surface where you're trying to draw it. If I say the area of Aditi's house is bigger than my house, what does it mean? Aditi's house has more space than my house. Yeah, that's what it means. So area is nothing but the space taken by something where you're trying to draw it. Now, other thing is perimeter. What is a perimeter? Anybody?
I don't see.
Yeah. Let's see, Tasvik. What Tasvik has to say? Tasvik, what is a perimeter?
Perimeter is the boundary of the whole.
Yeah. Nihan, is that your understanding as well?
Yeah, I was about to say like the outline.
Outline or the length of the border, basically. Yeah.
Yeah.
So if I'm talking about the perimeter of this circle, this is from here to here till I make a complete circle. If I talk about the perimeter of this one, I'm talking about this whole string which will cover this one. If I talk about a rectangle, what is the perimeter? I'm talking about this length plus this length plus this length plus this length. Okay. So perimeter is nothing but the boundary. If you talk about perimeter of any shape, you are essentially talking about the boundary. Or imagine this way. Let's say you have a farm. Okay. And when you say perimeter of the farm, you're essentially talking about the length of the barricade you would need for covering your farm. Yeah. That's just an example. If I talk about the perimeter of the room, you're talking about what is the length of the wire you would need for covering all the boundaries. Yeah. So perimeter is the length of the boundary and area is the total space taken. Okay. Area is this. Area is the total space taken by the object on the surface, and perimeter is the red part, the length of the red part. So you talk about perimeter of this guy, this is the red part, this is the red part. You're talking about the perimeter of this guy, you're talking about all the sides length. When you talk about area, you're talking about the blue part. Yeah. So this is where we will end our class today. I'll let you guys go. Enjoy the rest of your evening. And tomorrow when we join, we will learn how to find out the formula for area and perimeter for different types of shapes. Alright?
Bye, sir.
Bye bye.
Bye, sir.
Bye bye.